All right. I'm going to click on, we're doing number 9. I'm going to click on the one which says period 8. You want to click on the one with your name on it. That's your copy of class notes, which is the period 8 notes. So if you missed class, you can get the notes through this document here. Also, again, there are these YouTube videos where I'm basically these class sessions are recorded, okay? Here we go. And let's see. We'll start with a little check-in. How are we all doing? How are we all doing? I'm in a decent mood, but I am tired today. I'm tired. But fortunately, it's Friday. I'm like a 1 or a 5. Yeah, 8 because it's Friday. Mitchell says 8 because it's Friday. Yeah. Day goes by faster when there's fewer kids in school. Ezekiel. Ezekiel's between a 1 and an 8, too. All right. So Ezekiel's also ecstatic. Tajnik's a 6. Tajnik is a 6. That looks like a look of surprise and wonderment to me. All right. Well, very good. Okay. All right. Learning targets. I can find a linear regression from a table. All right. We have data in a table. We put that data in our calculators, and then we go, stat, calc, and run a regression. Either linreg is the one we're looking for. That's how we do that linear regression. It'll give us y equals a times x plus b in the calculator. And it also tells us what a equals and what b equals. Well, we just write that formula out and we put in the number for a, put the number for b. That's linear regression. Correlation coefficient. I can find the correlation coefficient. That learning target is all about turning on stat diagnostics on, looking at the R value when we run the regression, and then if that R value is, let's see, if it's 0.75 to 0.999, that's a strong correlation. If it's a 1, that's a perfect correlation, positive correlation. A -1 is a perfect negative correlation. Correlation of like R value of like R equals 0.5 to 0.74, that's like a moderate. Anything less than a 0.50 absolute value is to a 0 is weak. And of course, a 0 is absolutely no correlation whatsoever. That there's no predictive value for x for y. All right, then the third learning target is I can make a residual plot on a calculator and decide if it's a good fit or not. So that residual plot is that where the model is the horizontal line, and we graph the residuals, the distance between the observed and the line, the expected value or predicted value. And if we don't see a pattern, if it's completely scattered, then yay, that means the model is roughly going in the same direction, has the same shape as the data. The data in the model, if the dots are scattered along the model, that means the model is going in the same direction as the data. If there happens to be a pattern in a residual plot, that's an indication that our model is not appropriate, because our data showing a pattern indicates that our data has a pattern or shape that's different from our model. All right, so if you see a pattern in a residual plot, it means it's not a good fit. And last but not least, I can find an exponential regression. That's about putting the data in your calculator, right? Stat, edit, putting the data in, going to stat, calc, exp, reg, and doing those regressions. All right. I think I did a review of all that stuff last time. So let me just skip to where we last. This is slide 11. Looking at slide 11, just for a quick review, remind you what we've done. This is a residual plot. This residual plot has a pattern. Therefore, we said this residual plot is telling us the model is not an appropriate fit. The model is not appropriate because the data is doing a different shape than the model. We would want something scattered if the model was appropriate. All right, on slide 12, we put this data in our calculators. We found the linear regression, and then we found the R value. The R value was 0.94. That's a very strong correlation coefficient, which tells us that there is a positive, strong relationship between the X values and the Y values, which suggests to us that, if we know what the X value is, we can predict the Y value with a strong amount of confidence. And then we plotted this residual graph here. And this residual graph here isn't showing a whole lot of pattern. It does make me wonder with these two dots at the ends when everything else is below. But, I'm not seeing a distinct U yet, so we can maybe say this might be scattered, or maybe not. We might have to take a look at different things. All right, we're looking at slide 14. Slide 14 is where we're picking up on this today. So make yourself get on to slide 14. Here's what we have. The relationship between the number of widgets. Now, widgets is just a word we use for somebody makes something. And when we give that something the term widget, we don't want to specify what we're talking about. So the relationship between the number of widgets in a package and the length of the package in inches is given in the table at the right. What is the slope of the line of best fit? Widgets on the x-axis, length on the y-axis. So here's our number of widgets. In this case, we got 3 widgets and the package is 9 inches. Over here we have 5 widgets and the package is 9.5 inches. With 6 widgets, it's 9 and 7.75 inches. All right, so this is our data. I want you to go ahead and visualize how you're going to solve this. How are you going to find the slope of the line of best fit here? I want you to try to do this on your own and visualize how you're going to do it. Before I go ahead and show you this first one here. All right. Step 1, I'm going to clear my calculator. Second plus 7, 1, 2. That resets everything. And then I could go ahead and turn my stat plot on if I wanted to. Second, y equals enter, enter. Turn the stat plot on. And then last but not least, turn on the stat diagnostics, just the mode button. Going up, stat diagnostics on, pressing enter, and there it is. My calculator's all set up. And I can begin to enter this data in my calculator. That's just easy as pressing stat and enter. Stat and enter. I get into this, what's called the lists menu. All right, L1 will be my X values. That's 3, enter. 4, enter. 5, enter. 6. All right, I'm getting those X values in there. And then I'm putting in the Y values. 9, 9.25, 9.50, and 9.75. Great. That is my calculator. Some of you have already got the regression line. I know that. But think, how are you going to run a linear regression from here? What buttons do you have to press? If you know, go ahead and do it. If you aren't sure, try something. By giving this a try, you'll be surprised. If you get it right, you'll get to have that reinforced. And if you get it wrong, your brain will be surprised, like, oh, I just remembered how to do this. And then you'll learn even more than if you got it right. You learn more by getting things wrong. All right, I'm going to press the stat button. I'm going to go over to the calc menu. And I'm going to go down to linreg. That's the linear regression, option number 4. I can press enter right now, or you can just press 4 in the beginning. It'll take you right there. I got to press enter like 5 or 6 more times. Once, twice, 3 times, 4 times, 5 times. And I get this kind of output. The question is, what is the slope of the line of best fit? Do we remember what the slope is? We're going to round to the nearest hundredths here. What is the slope? Well, I'm hoping that y equals mx plus b starts to open up some neural pathways. Y equals m times x plus b, where m is the slope and b is the y-intercept. We're trying to find the slope. We're looking at this calculator. Calculator wants to be funny, and it's going to tell us y equals a times x plus b. A is just another term for m, right? It's just the number being multiplied by x. That's our slope. that determines how this is changing for every increase in x. The slope equals 0.25. That's the slope. The y-intercept, I actually already mentioned it. All right, if a is the slope, what is the value of the y-intercept? Well, I'm hoping you didn't wait for me. That you look at this like, oh, it's got to be 8.25, right? It's the b. This is pretty easy. It's pretty easy. Well, this is just a warm up. This is just a warm up for the next slide. Move over to slide 15 in just a few seconds. I'll stop. I'm going to introduce the next problem, and then I'm going to stop sharing, give you time to work on this. All right, moving over to slide 15 and 5, 4, 3, 2, 1. There we are. Slide 15. A cup of hot coffee is poured into a travel mug. The mug is taken out into the wintry weather and begins to cool down over 5 minutes. Using an exponential regression equation, I'll say it again, using an exponential regression equation, one more time, an exponential regression equation to model the drop in temperature. Predict the temperature of the coffee after 6 minutes to the nearest degree. Time is your x-axis, temperature is your y-axis. Just to help you remember, this is time in minutes. All right, that's our x value. Our x is time in minutes. Our y value, I didn't move very much at all, did it? Our temperature is our y values there. All right, I'll stop sharing and give you time to run this exponential regression. When you've got it, you can hit me up in the chat. I think some of you probably already have it.